My name is Stephanie Wiegraff, and I worked in an environmental engineering lab this summer. Environmental engineers design ways to improve air quality, soil quality, and water quality. I focused on improving water quality. This is the water cycle. First, water evaporates from the streams, lakes, and other bodies of water. Next, the water condenses in the air, forming clouds. Last, precipitation in the form of rain, snow, or sleet falls from the clouds and runs off back into the bodies of water, or it soaks into the ground. The water that soaks into the ground is called groundwater. This water is stored in the spaces between soil particles deep in the ground. When humans need to use this water, we use a well to move it above ground. We use groundwater for some pretty important things, like for drinking, bathing, and watering our crops. Sometimes the groundwater that we use gets so dirty that it is harmful for humans to use it. This is called groundwater contamination. Groundwater contamination occurs when man-made products or natural materials come in contact with the water that's being stored underground. These materials dissolve and contaminates the groundwater. A couple examples of these harmful materials are fertilizers, gasoline, or naturally occurring lead. In order to design solutions that will make the water safe enough for everyday use, environmental engineers study how easily the contaminated water flows through the soil. However, it's very difficult to study how contaminated groundwater moves through the soil since it happens so deep underground. Engineers can recreate this process of groundwater contamination in the lab in order to better study the problem. In my lab, I use column experiments to represent the groundwater contamination processes that are occurring underground. A glass tube that is positioned vertically is filled with a couple inches of sand. The sand represents the natural environment in which groundwater contamination typically occurs, such as soil. Sand and soil are very similar. They both have pores or open spaces that contaminated water can fill in. I used an orange solution called hematite to represent contaminated groundwater. In each experiment, I added a different type of acid to the orange solution. The solution either moved through the sand very quickly, very slowly, or not at all, depending on which acid was added. The acids that were added were acids that are naturally found in the ground. Knowing which types of acids cause the contaminated water to move faster or slower can help scientists and engineers better predict how contaminated water moves through the ground. If we know how quickly the contaminated water moves through the ground, we can engineer better methods of treating the contaminated water before we use it as humans. One way that environmental engineers treat the contaminated water is through the use of filters. Filters are designed so that the contaminants are taken out of the water, but clean, drinkable water is collected. Can you design a filter that will help separate the contaminants from the rest of the water?